Its mass is 20 times more than our Sun's, its diameter more than 700 times greater, and its illumination 7,500 times brighter than our own friendly neighborhood star Sol. To give you an idea of its size, if you put it in the center of our solar system, it would encompass and devour everything out to the orbit of Jupiter. Look here at our Sun in front of your eyes. It's actually quite dark and tiny, isn't it? Compare that with the star Eta Carinae. At its peak brightness in 1843, it had a brilliance estimated at more than 50 million times that of our Sun, and is several hundred times larger. But that's nothing. Take a look at this beauty. Betelgeuse. It has a size 300 times greater than that of Eta Carinae. Betelgeuse is the second brightest star in the constellation of Orion. Now, scientists know that Betelgeuse has existed for more than 10 million years. But because of its high mass, it is also known that very soon, relatively speaking, it will cease to exist. And this in turn means that we may actually bear witness to an unusually rare and beautiful sight, a supernova, the explosion of a star. Nobody doubted that journalists, unable to help themselves, would turn everything upside down and inflate and distort the story of this unprecedented sensation. Thus, the Betelgeuse explosion at one time fell into the coveted menu of accidents that would happen on December 21st, 2012, and was presented as another apocalypse bearing down on the Earth. But the fact that the event fell into the same basket as the prophecies of the Maya and the reptilians of Sumer does not mean that we should treat it with the same skepticism. Alpha Orionis really will explode. But when exactly, and what will happen to us? It is interesting that at the time of Michelson and Pisa, this star was considered to be relatively close to us. At that time, scientists estimated the distance to the star as around 35 parsecs, roughly 114 light-years away. Preference began to be given to larger numbers, but a huge uncertainty appeared towards the end of the 20th century, as the distance to the object was then estimated as being anywhere from 100 to 1,000 parsecs. The problem is that the only direct method for determining interstellar distances is the method of trigonometric parallaxes, and it requires an exceptionally precise determination of the coordinates of the star. And how do you determine such a thing if light spots melt on its surface and the distances between them are comparable or even exceed the expected value of annual parallax? Anyway, all this sounds a little too demanding for even the most educated of us non-physicists. Interestingly, the star Betelgeuse is not round. Its sphere is very, very far from a perfectly symmetrical glowing circle, and this makes it quite problematic to measure the distance to the star. Even a cosmic astrometry telescope, the European Space Agency's Hipparcos, launched in 1989, could not clarify the precise galactic location of Betelgeuse. According to its data, the distance to Alpha Orionis was between 130 and 150 parsecs. This value makes one wonder about the origin of Betelgeuse. Such massive stars are not born singly, but are usually found in so-called stellar nurseries with other stars of a similar nature nearby. Because it is now in relative isolation from other stars, it is obvious that through some process it was thrown out or ejected from its parent star cluster in the past, and that this must have happened relatively recently, as stars of this type are always short-lived. Since we know the movement of Betelgeuse now, we can rewind its trajectory into the past. Here, in fact, it turns out that if the star is 130 parsecs from us, then there is not a single cluster in its past path from which it could have been born. This mystery stirred up the bright minds of mankind until 2008, when astrophysicist Graham Harper and his co-authors supplemented the data of the Hipparcos Space Telescope with parallels of Betelgeuse in the radio range, using the illustrious VLA Interferometer Observatory in New Mexico. The refined result pushed the star back to a distance of 200 parsecs, so that its trajectory approached the only place in the entire district where the star could have possibly been born. This turned out to be the right place. This stellar association consists of several tens of hot red supergiant stars of the spectral classes O and B. Proceeding from all of this, the scientists concluded, quote, "It is possible that Betelgeuse had an even more massive star partner at birth," end quote. This partner star exploded about 1 million years ago, and Betelgeuse was propelled by the monstrous blast and flew out of the group of stars toward the plane of the galaxy at a speed of about 35 kilometers a second, resulting from the so-called sling effect. At least that's the way Dmitry Vibe of the Institute of Astronomy of the Russian Academy of Sciences describes these events. The distance of 200 parsecs not only solves the problem of the origin of Alpha Orionis, but also forecasts an endpoint, predicting Betelgeuse's future destiny and demise. Previous estimates of the distance to the star did not exclude a scenario in which Alpha Orionis could die a simpler death like that of a white dwarf with a planetary nebula. The 200 parsecs distance leaves this scenario in the dust. For the huge mass of the star, which, as you already know, is 20 times that of our Sun, leads to but one conclusion. An imminent final eruption of a supernova is all that can follow. When will this happen? At any time. It is even possible that it has already happened. As Betelgeuse is more than 600 light-years away, that means that even if it exploded last night, then we would only be able to see this grand spectacle no earlier than 600 years from now. But in reality, of course, nothing is ever quite so simple. Details of the evolution of such massive stars depend heavily on several factors that are difficult to measure, specifically the rotational speed of the star and the rate of loss of matter from its surface. In particular, some massive stars, after the red supergiant stage, are temporarily or forever transformed into blue supergiants. Specifically for Betelgeuse, 3 options are possible. 1, it was always a red supergiant and will remain so until exploding. 2, it will take some time to go to the blue supergiant stage and explode at that stage, as happened with supernova precursor SN 1987A. Or 3, it started as a red supergiant, then turned into a blue supergiant, and then back again to red. In the first and third cases, an explosion really can occur at any time. In the second, many thousands of years remain before such an event, and the approaching end will be announced by the movement of Betelgeuse to the left of the Hertzsprung-Russell diagram. In general, the explode at any time possibility seems quite plausible. But we must remember that the current activity of Betelgeuse does not indicate an approaching end in any way. These are not convulsions, but convection. It's just that Betelgeuse has an heroic character, as befits a star of such caliber. And finally, and this is the most interesting thing, what will happen to us when Betelgeuse explodes? What will happen to our planet after the explosion of Eta Carinae? Which stars are worth being afraid of, and which do not threaten us more than a dandelion? But enough for today. Perhaps we will continue this story another time. Put like, subscribe to the channel. Thank you for your attention, and see you soon.